Welcome back, everyone. It is week 2, day 2 of Python. We are in the afternoon lecture, and we're going to keep exploring the ERD models in Python. So let's go ahead and take a look at the platform first, and then I'm going to pull up my SQL in front of us right now. Okay, so here I am. If I go here, we don't need anything here, do we? Well, first let's recall, what is an ERD? Anyone remember the acronym, what it stands for? No, I see Oriole still chewing. He gets an exception. But for everyone else, entity relationship diagram. Yes, entity relationship diagram. So what that means is it's a blueprint. It's a blueprint for how the data is going to look when it's set up. So this is what we are talking about. This is an ERD, an entity relationship diagram. Here is a it shows users and followers and the relationship between each other. So let's talk first about what type of data we would be saving to our database, right? So let's talk about this as our database. And what sort of objects have we created so far? Let's talk about the stuff we've created last Friday when we were entering users. Exactly. Thank you. All right. So let's say a user has a first name. Yes, we're talking about the types of data where we would enter into an object that would create and hold a user. So let's think of first name, last name. What else?
ID.
Password, right? And then maybe age somewhere in there. All this sort of stuff here. But when we create a database, when we create, like, let's say a table for, I'm going to call this one users. Any table that we have, as you see here, is going to have an ID. And that's because our data is saved, as I mentioned this morning, in columns and rows. Okay, so here's what I mean by that. Let's move this first name over to the right. And it's going to be its own column, as well as this one here. Last name. And I'm going to move age here and password here. And the reason I did that is because each category is going to be what's called its own column. And as I mentioned, the only difference now that we are entering into our object that holds our user's information is an ID. And the reason is because an ID is gonna be our connection. It's gonna be our point of contact between tables. And I'm gonna speak to that in just a minute, but we here have an example of types of data relationship. We had one this morning about cities and addresses, how one city could have many addresses, and what was the other one? One country can have many cities, or one state can have many cities. So those are all entities in the diagram, and how they relate to each other is through the IDs. The ID is the key by which we can connect the tables of data. So in this instance here, I just have one just plain and simple called ID, and then I have these other bits of information that I'm going to store into our users database. So let's say I were to save something into this users, what I'm going to call, well, what's called users table. All right. Each collection of data is going to be called a table. And so I'm going to give this one the ID of 1 because this is the very first one that I have as an entry in my users table, in my users database, right? This is maybe a database for a like a social media website, right? Let's make it a social media website database. And in our website, we have a users table. We have our first user, very first user. And what's his name? His name is Tom, because that's the first user of MySpace. And I don't know Tom's last name. I don't know if anyone does. It doesn't matter. Bombadil is his last name. And he is 100 years old. His password is ABC. Okay. So here is our first entry. And our second ID would be, well, let's give it an ID of 2. Okay, this is because it's our second entry. And this guy's name is going to be, let's see, Frank Rosalino. Okay, I'm just throwing names out now. And he's 55. And he's, his password is fish. I don't know. Okay. So yes, Mickey, I see your question in the chat. I am definitely going to demo how to make this workbench in the schema. Yes, that's the goal for today. But before I do that, I'm showing you what a table is and what it looks like and why it's organized this way. Okay, so yes, excellent question. That is the goal. I'm going to pivot there. But what I want to show us is that when we create a table, this is essentially what we're creating. We're creating rows and columns, as you see here. And when we are grabbing information from our table, we are grabbing from like either a row or a column, right? So let's say you want to find, let's do one more entry, okay, for the sake of making this a good explanation. So Bob, and his name is Lamborghini. Bob Lamborghini. And then Bob is 12. And his password is it's a good one. Okay. All right. So let's say we want to find all of our users that are greater than whose age is greater than 40, right? Then it would search our users table and then it would look into the age column and it would find all the users that have age above 40 and it would say, okay, here's your users. 1 and 2. They have the ID of 1 and 2. They're Tom and Frank. And so here's the 2 users. One's 100, one's 55. Let's say you asked, let's say you asked your database. Let's say you ask your database, I want all my users who have an ID greater than 1. Okay, so the ID greater than 1, all right, it would look into the IDs, it would sort, okay, if all the ones greater than 1, and so you would turn these 2 rows here. It would return 2 rows. So you could search by, and when you are, you can say, like, let's say you want to grab a certain particular user. You can say, grab all the users with the ID of 2, right? There's only going to be 1, so that would be a select 1, right, from our CRUD features. And I see, Brooks, your hands is raised.
Yeah, I'm just still a little bit foggy on why we started with the index of 1 and not 0. I'm still a little confused on that.
Oh, for the IDs?
Yeah, like where
Oh,
would index of 0 be
I
referring?
could, well, okay, that's because, well, by default, our SQL database is going to save it from 1. Whenever we number things from 0, it's typically when it in regards to an array. So that's a good question. How come how come we're not consistent when we're indexing things? Just different languages have different indices on which they start, right? Even different cultures in different countries. Mostly American culture, we start counting from one, but I think other cultures they can count from zero.
Okay, thank you.
Yeah, and so that's a good question. I've wondered that too. Yeah, so MySQL, that's good to know. Whenever we create rows of data in our database, it's going to start numbering them with incrementing IDs starting from one. So that's a good question. Never been asked that. All right, so let's continue. All right, so here's an example of a users table. And all the passwords are stored in the password column, age on the age column, and so you get the picture, right? So we would, if we want to find something by the column name, then we can find that information in that column. And it for the results that we find, we can return that row of data. And so we'll get a better visualization. But what I want us to see, the number one thing that I want us to see is that what we're creating in MySQL are tables that look like this. Tables that look like this with the names of the rows. Sorry, the names of the columns got mixed up there. Let me bold this. Names of the columns and how they're organized into rows as such. Okay, so let's go ahead and create some of these on MySQL. Oh, no, wrong page. All right, we still need a little bit of uh, information before we start creating these diagrams. We need a little bit more information uh, before we're fully able to take advantage of MySQL. But let's get started with something simple. Let's just create what I already had created here. And then we'll show us how we can get that, the first part of creating a table started. All right, so let's go ahead and open up MySQL. I'm pulling up the workbench now. You guys should be able to have this open at this point, be able to see this. Okay, and if I click here to this triple square with the lines pointing to the center of the one on the right, so that one there, that's going to be our ERD models section. So we can click this plus sign. And here is where we are going to begin the process of creating a database. Okay, so what I want to do first is rename my database. I'm going to call this one, what did I call this? Social media website database. Okay. And then what's the next process here? I want to add a diagram. So let me pull this up here. Add a diagram. And the first step is to click this button here. I wish I could expand this to make it bigger, but I'll just highlight it with my pen here. This one here. Click it. That's going to give you the option to enter in a table. And so this table here, it's now, let me fully expand this. All right, so here I am. Here's the table. I want to name it my users table, right? So I'm going to say users, and there's my table. Now I need to fill it in with those columns, the columns that I had mentioned that we needed to fill it in with here. So I'll put it side by side so we can see what we need. Austin, you don't see any of these options on Workbench?
No, I don't see anything.
Hmm. Okay, we'll continue this tutorial after class. Let's get this down for the sake of the recording, and then we'll troubleshoot with everybody if the MySQL Workbench isn't working the way it should. Okay. Now let's continue. Here I have my users table. I said I needed to enter in the columns that I see here in this table. So the first one I want to enter in is going to be this ID. So I'll just call it, I'll rename it from what it already is. The moment you click into it, it's going to have that option pre-filled for you. It's going to say ID users, but change that just to ID. Okay. Then you can click out of it and it's saved as such with that little key there. All right. And your ID is going to be an integer because it's going to be a number. And here you can see, let's see if I can expand this a little better for a moment. You see the different options of types of data that you can choose. And here I have int, and then we'll go over what some of them are. You don't need to know what all of them are, but we'll go over the most important ones in just a minute. But these are types of data that as they are saved into your database. Okay, so if I click int, there I have my ID. And what I want to click here in this column as well is this checkbox that says AI. And what this does is make it it makes your ID artificial intelligence. No, it doesn't stand for that. It stands for auto increment, as you can see in this bottom right corner over here. AI stands for auto increment. So what that means is anytime something is automatically added to your table, it's going to increment from the ID of 1, and then 2, and then 3, then 4. Okay, so this is going to be something you always select when you're creating when you're entering the ID part of your table. Auto increment for your IDs. Take a note of that. Okay, so now let's continue. We said we need more than an ID, though. That's just the way that we're going to identify that row of information for that entry. The next bit we need to enter in is, well, we said in our example is the first name. And we want to keep this style consistent. The way that we're entering the names of data, let's keep it what we call snake case, right? So that means lowercase and underscores in our column names and no spaces. Okay, so keep it snake case. And now here we're going to look into what we can enter here as a valid data type for what we want to be like a string, right? We want first name to be a string when we enter it in as a well, when we receive that data, right? Because think about it, how is a first name going to be entered? It's going to be on an HTML form. That's going to be given in, and then when we put that input type, it's going to either be int or text or some other type of HTML data selection. So we're going to select input type text, and that's going to send the data into session as a string when we collect it in our object that we'll send back to our place here that says this varchar means various characters that you can select from, so numbers and letters in a string. And here you want to decide how long you're able to make it. And you can make it up to 255 characters long. Do you always need it to be that long? No. You can limit the amount of characters that you would have to be your first name. Let's say 45 is a good length, right? Because who has a length of 45 characters as their first name? Maybe some people. Yeah, maybe some people have multiple parts of their first name. But let's just say, for the sake of limiting the amount of data that we want entered in our first name, we're going to limit the amount of characters that they can enter. So we'll say 45 characters. That is 45 letters or numbers in their name. This one we don't need to have auto incremented. Oh, and I think I should have mentioned one other thing before I continue on too much with my uh, explanation of different types here. So now you can compare the first entry to the ID. And we see a little bit of difference already, right? See, look at this row. This row here, it's kind of naked compared to the one above it, right? This doesn't have this checked, doesn't have this checked, definitely doesn't auto increment because we're not going to auto increment names. That's not possible. The data type is different, but we could have other data types that could be integers, so that's not such a big concern. What I want us to notice is that this entry, the one above, like I said, it's the key. So it's very important. It's going to be called the primary key as well, as you can see here, PK. And that means that there's going to be possibly more than one key in this table. Keys may be from other tables, but the key that is inherent to this entry or to this table, the key that identifies with this table is going to be called the primary key. So that's why we select PK. The other thing that's selected here is the not null option, as you can see at the bottom right over here. That means that no key in our table is going to have a value of null. If there's an entry, there's not going to be, you can miss maybe the age or the last name, for example, but you can't have an entry without a ID. So let me just give a visual for this real quick. Here in this example, we're not going to have an entry where Bob is there with his first and last name, but he wouldn't have an ID. Every ID gets created as soon as an entry is created. So that's what that means. Not null, double N. Alrighty, let's continue. And before I continue, let's do a poll check. How are we doing? Do we understand so far how to create a table, how to create an ID, and something that would be the first name entry, as well as what data types are int and varchar? Okay, we're just creating a table. This would be the final resting place of where the objects that we create and their changes to data would be stored here in this MySQL workbench. All right. So let's continue. We have our first name. All right. I see that some varied results, but for the most part, we're above not understanding at all. So it looks like we're almost there. Let's create another one. Let's create last name. Last underscore name. Here it is. And we're going to give it also a varchar for 45 characters. That's fine. Age, we know age is only a number, right? As the saying goes. But really, it's not going to be a number and a letter. Okay, so we're going to switch it back to int. And let's add something to our table here. Let's add let's see if I can move this over. Let's add this like a bio. Okay. Let's add like a bio section. So this is just going to be like someone's life story or something. And so for this table entry, let's see. I want the characters to be more than 45 characters long. This is going to be something that will be a longer entry. So I'll say this could be up to the max amount of characters possible for varchar to hold, 255. Now let me see here if there's one that holds more than that. Let's look at the different options that we have here. we have date, and we do want to take advantage of these. So let's go ahead and do that. Last thing that, oh, wait, we missed one. We missed one. Password. Password. Password needs to be, I think it's just a varchar of a limit of a password that you want. So here we are, varchar, and then we can make that 255 as well. That, in fact, we do want to make 255 because let's get in the habit of doing this, because at some point we're going to use up the max amount of characters always for a password. That's because we have to scramble our passwords, and we'll get to that next week. Yes. So for password, there we have a max limit of characters. And then what was the other, let's see, option here? We want to also, in our table, always create these things as well. A created at and an updated at. And we'll switch these to date time and date time. This is going to give our entry for whatever user that was created a time that this was created, and the time anything would have been updated in this table. So I'm going to say also right here in this default expression, you have to add this now. And there's another one here that I think is just update on now. I think it's in the it's either in the platform, I have to pull it out of a note here. So give me a second to remember that. Unless an instructor wants to throw me a line here. I think it's just now. It'd be if
Oh, that. Updated that.
Now at update or now on update now.
okay.
You can also
Uh,
right click on it, and then there's some options there that will just autofill it for you.
Oh, okay.
So,
Hmm.
I think it's in one of the, yeah, there it is. You
Yep.
see?
All the way down at the bottom. Current timestamp on update, current timestamp.
Wow. Okay. I had to get up to see that because it was blocking that part of the screen. Okay. Thank you, instructors. Instructors to the rescue. All right. Did you see how that was done? Let me redo that in case we need to see that. Okay. I'm going to delete it and then restart that. So for these last two entries in our table, we want a default expression here in this column that we're seeing here. For the first one, I just clicked in. Let's see. Double click in, and then you can say now, NOW, and then that parentheses there. And this one here, the way to get this one correct is by saying NOW, open the parentheses, click out, click back in, right click it, and then the option at the very bottom, default current timestamp on update current timestamp. There, it's a handful of words to say. So let's keep this as such. All right, keep the updated at, created at, and updated at as you see here. This here now looks like a full table. This is able to receive, these columns now are ready to receive data. And I know on this sense, they're rows, right? These are like rows that we're selecting, but they're actually for columns that would be seen like this in our information that's saved. Okay, it looks like this, even though when we start creating our columns, we're putting them in well, rows here. Okay, so once we have this checked, once we have this part done, we are ready to either one, make a new table, all right, and then either make some relationship between the tables, or I could, let's say our website only has users. Maybe there's no posts, maybe there's no likes, maybe there's no messages, nothing. all we have are users. That could be like a, like a website where you just have a blog or something. Oh, well, you would still need to have like a post or something on a blog. So what kind of website only takes in users? I don't know. Some kind of funny old website. But the point is, this is enough to create a database with. Okay? And I can either choose to create a database now or make some relationship with the models. And I think I'm going to hold off on making a database until I make another table here. Okay? So I'm going to make one more table here and then make a relationship between these tables, these points of data. And then once that's done, then I will finalize this as a database that can be viewed in memory. Okay, so then you can have entries in for wherever we see these columns. So we can give information like this as we have done in our imaginary database here. We'll fill in information once we're at the final step after we've created this database that holds. Right now, this isn't a database yet. This is just a model for a database. Okay, this is just a model, an ERD, and we can use this as a template to create a database. Okay, so let's look now at the platform, and let's look at what types of relationships our tables can have. Okay. All right. And this here we'll return to because we haven't talked about what foreign keys are yet. But so far, all of this is something we've covered. We've made the table names lowercase. We've made ID the primary key. We've added a created at and updated at in addition to our entries. Now let's look here for a minute. What types of entries that we are able to give? Let's just recap here. Varchar is a number of characters, and it can be a variety of characters there. So this would be good for email, first name, and last name. This is also used to store characters. Int is for integers, for numbers. Big int is for really big numbers. Tiny int is for numbers that are relatively small. Okay, something from like 0 to 9. Okay, then we have float. Anyone know what float meant? Remember what that means? Floating decimal point numbers? Yes, decimal places. They have decimal places. I'm answering my own questions here. I'm Blue's Clues. All right, text. It's just like varchar. It's for holding text. Date time. We use this. Remember, we use date time to record our updated at and created at. Let's see. Date time. Here it is. Shows us the date and time our columns for created at and updated at show here. Okay, and now with this, let's look at different types of relationships that we can encounter and what they mean. What do I mean by relationships? Okay. So, in this instance, we have this table here, customers and addresses. Customers and addresses. So imagine we have a website where we have data saved that holds our customers' information like their first and last name and their addresses where they live. We've all done this on some sort of website. We bought something, Amazon, anything else. And so let's say you don't want to have in this customers table the street, the city, the state, zip code. That would just put too much information into one table. right? It would just be too much information. Let's say when you look up a customer, you just want to know their first name and last name by their ID, right? And you don't need to have all this information in one table. So that's the purpose of separating information out, right? So we can, let's say, add to our social media, um, uh, let's say, website. We need to add, well, we want to add another table. We want to add more things related to what a social media website may have, right? Like posts or likes on a post or comments or maybe like messages. So what's the relationship between those points of data, those tables, and the users tables? That's what we're asking at this point, right? When we create another table where users would have to post, instead of putting that post information in the users table, we're going to just create a separate table that's just for posts. Okay, so let's say in our social media website, we have one that's like this for posts. All right, so we want to add the ID. We want to say auto increment. As soon as we click the auto increment here after the set to ID, it should be set just like that. And maybe a post will have a title. And this can be a short title, so we'll leave it as such. And then we'll say post content. What's the content of your post? The main content. And we'll make that one. Let's see here. There was one long text, right? Maybe that it could be a long text so that it'll fill that up. What was the other one that we saw on the platform? I believe it was called, is that it? Long text? Text. Yeah. Okay. So text is good enough. So long text would be even better. All right. So let's continue. And so we have our tables pretty much complete at this point. Now that they're existing, right, in our imaginary our blueprint for our database, we want to understand how they relate to one another. Okay, so we have posts and users. And in this case, let's switch back to our e-commerce website. Whenever someone is created as a customer on our website, each customer is only going to have one address. Can someone have more than one address? Yes, if they have more than one house, sure. But in our instance, we only need one address per customer. So in that sense, it's a one-to-one relationship of data. One customer per address. We're not going to have two addresses per customer. We're not going to have more than one customer to an address. We're just going to say one address per customer. Okay? So this is a one-to-one relationship. Let's say we add an address table in our table as well. All right, so we'll leave that post there. And we will say addresses. Let's say our social media website, you can buy stuff as well. And here, and this, we want to give it an ID just as we see there. Let's copy this model. So I'm going to say ID, auto increment, and then I'm going to say this one's going to have a street, city, and for street, let's leave a little bit more option just as we saw there on the example. I'm looking here. And so city, state, let's leave that as is, and then zip code. And we'll switch that to int. Okay, So now we have 3 tables on our ERD. What we want to do is say, just as there's only going to be 1 user per address, we're going to make a 1-to-1 relationship with this model here. 1 address per customer. And the way to establish that relationship is by using these tools that you see here. You have to expand this out to see them in full. But we're going to look here at this one here where it says 1-to-1. There's this like 1:1 here. And so we're using this option. So click that there. And once you do that, you will be able to click a table. So click a table and then click the table you want it to be connected to. All right, so then I click this table and there you see the line. There now is a connection. No matter where I drag it, there's going to be this little a line that connects. Now, excuse me. And so what I want to do now is before I continue is to organize my table a little bit, because as you can see, something was just created when I did that. Did anyone see that? All right, let me show you, Johnny. I see your comment. The first button you want to click is this one right here. That's going to establish a relationship. There's lots of relationship ones. You want to be careful where you click here, because you can click the wrong one and establish a wrong type of relationship. So we want to say 1-to-1. So click a 1-to-1. Because we're going to say only 1 address per user. You have to have a unique address, right? When you do that, okay, when you do that, you'll see at the very bottom that it will add another column here. It says users _ ID. All right, what this is what we mentioned previously that we were going to explain, which is the foreign key. And when we have a foreign key, it's good to make a habit of deleting that plural and just call it user ID. Because it's going to say this is the ID of the user that we are connecting to the address. So then I would suggest you also move it up to keep your keys in one area. So you just click move up a couple times, then you have your ID, you have your keys sorted at the top. Okay, so this is the ID for the address entry, and this is the ID of the user connected with this address. Okay, now I see a couple hand raised. Nian and Jacob. Nian, would you go first?
My first question is, what's the difference between the dash 1-to-1 and the solid line 1-to-1?
That is a good question. So, I used to have that answer at the top of my head, but I think I'm drawing a blank at this point, unless another instructor wants to step in, before I recall to memory what the difference is here. I know that we want to select the dashed one. The difference between a non-identifying relationship and an identifying relationship. So, so let's see here. Vincent has given us the link that we need to explore that. Okay, so here we have a bit of description. All right, so for now, because we have a lot of information thrown at us, all I want us to know is to select the dotted one for now. Okay, I'm giving us a lot of information to digest, but if you want to do some deeper searching as to why we are telling you to do this, follow the link here, and it's on the video if you want to see. Okay, I'd encourage you to keep doing some research on that as well, and see if you can come up with a better answer in the end.
If I may
Okay,
provide a brief explanation.
Yes, Kyle, perfect.
Yes. So identifying relationships versus non-identifying relationships, right? Okay, so when we talk about relationships between to different kinds of tables in SQL. The way that one table can tell that it is associated with another table is through the foreign key, right? So like in our example here, we could see addresses knows which user it belongs to because of the user ID. That's the foreign key, right? So an identifying relationship is essentially saying that this address cannot exist without a user. So the primary key, so the foreign key essentially becomes the primary key. Some of you may have seen this already working on the many-to-many relationships in the assignments when it turns, when there's no yellow one, there's just red ones. That is an identifying relationship. So that means that it has to have the other two exist, and its existence is identified by the relationship it has to its parent table. So with a non-identifying relationship, the one we're working with, means that they can relate to each other however they choose. And it doesn't. So for example, if we were to have an identifying relationship between users and addresses, so that would essentially be there's no ID for addresses. The only way it exists is it belongs to a user. So does that make sense? Okay.
That was a very thorough answer, Kyle. I think we were just lacking maybe probably some visualization there, and that's because you're working from my screen here.
Yeah.
But thank you very much, Kyle, for that explanation. I think what if I were to sum it up? Let me try to sum that up, Kyle. So if what it's saying here is that an identifying relationship is one where, oh, I see. There is a dependency on another table there for its existence. I get it. Okay. So in this case, a many-to-many table is going to have to be an identifying relationship because it's going to have only foreign keys. So let me see if I can break that down. Is that correct?
Yeah, so like if you pull out the many-to-many tool real quick and just like drop a random one between what's
Well,
that
I wanted
called?
to get to that, I guess, when we were going to get to the many-to-many tables. I didn't fully explain all the different types of relationships yet. So that
Well,
question kind of beats us to that explanation.
we could get to that in a second, but I'll just show you the basics. You see that many-to-many, so
Yeah.
click on many-to-many and then just posts and addresses. We'll just delete it.
Okay.
Let's see, look at that. Notice that that table does not have a primary key, whereas our other tables require primary keys. But this one does not have a primary key, so how does it exist? Well, it exists based off of those foreign keys. That's what tells it who it is, so to speak. You can also create many-to-many relationships with non-identifying many-to-many relationships, which would essentially mean the middle table, for your understanding, Josh, is not dependent on the others. But we would be able to create another table that just has foreign keys.
Okay. Gotcha.
So and we'll get a chance to address many-to-manys in a second, but that's an example of an identifying relation or an identifying relationship.
Right. So as soon as you make that connection, then it has that table there that it had created. So we'll get to explaining that thoroughly in just a moment. But great questions so far. I'm seeing that you guys are asking great questions. And Yen, did you have another question?
Yeah, so after you click one-to-one relationship, how do I know which one to start from the table and the end table? So from where to where?
So with the one-to-one relationship, you want to start. I don't think it matters, right? So oh, it does matter. Okay. Let me then rewind. All right. The one that you want the foreign key on is the one you click first. Okay. So let me delete this connection here. delete. See, when I deleted that, when I created that connection, if I click here, posts, and I want posts, one user per post, and I want the foreign key to be on the post, which is usually the case here. I would click that first and then drag it over to users. That will establish the foreign key on this table. It's a matter of preference as well, but that's how you would know what table to click first, wherever you would determine the foreign key to be. In this case, I want my user ID, my foreign key to be in my addresses. We can do it the other way around as well. Let's see here. Delete, and then I'll delete this one as well. Delete this one. Yes. And I will click the other way around. Oops, it didn't click the way I wanted. Let me delete it. Delete. Okay, so now I will go in here, wherever the foreign key appears, you need to go in and do some slight changes here to make it a better foreign key. So I'm going to change it by removing that plural address ID. And then I'm going to move this to the top. So wherever you click first is where that foreign ID is going to be created on that table. Does that answer your question, Ian?
Yes, thank you.
Okay, awesome. Awesome. And who else had their hand raised? I saw someone else. If you want to still ask your question, let me know. But
Yeah, I
was it
gonna
Simon?
ask- It was me.
Okay, sorry, I'm not seeing your face on Zoom. Go ahead,
Yeah, I was gonna ask,
Jacob. Yeah.
when you're creating a relationship between two tables, does it make a difference, which table the foreign key belongs to? So for like querying purposes, or does it not matter at all?
It doesn't matter. And is there Vincent or Kyle, can you confirm that? It doesn't matter where the foreign key is. It's a matter of preference, correct?
It matters to an extent. So for example, well, actually, the foreign key does matter a lot. With a one-to-one relationship, not so much, but with a one-to-many relationship, it does matter.
Okay, that's
Because
what I
the
want to answer.
one-
The one-to-one
the one-
relationship.
Oh yeah, for the one-to-one, the thing about one-to-ones is that they basically behave exactly the same as one-to-manys, and it's almost like you would only really use it for normalization. But they behave very similar to one-to-manys. I would say, yeah, for one-to-ones, it shouldn't matter too much.
It matters only to you as the developer wanting to know where that foreign key is, that you can use it to grab that information, because that key matters when you want to make calls to the data, right? So you need to know where that foreign key exists in which table. So if you want to keep yourself organized that way, like let's say, sorry to cut you off there, but thank you, Kyle. I appreciate that. All right, so where we go from here. We were trying to explain foreign key and addresses. Okay, in this instance, the foreign key is saved in the customer's ID. But you can have the customer's foreign key in the address's ID. I would personally choose this way. This makes more sense to me visually. I mean, if I look at a user, I know each user has an address, and that address is going to be grabbed through that address ID, so that I can go ahead and make that connection there. Now, we've only explored one type of relationship. There's two more types of relationships that we have to explore in order to finish our diagram and understanding of how we can diagram something. Okay, so the next type of relationship that we're going to explore is a one-to-many. One-to-many. And in this instance, one customer And we know that, well, each customer has an address, but that's not what we're seeing in this table. That's connected to the other one, but it has an ID. And each customer, though, has, well, a customer can have many orders, right? Whenever you make an order on Amazon, you're one customer. You're just one with many orders. And so in our instance here, we have a social media website. One user can have many posts, right? One user can have many posts. So what we'll do to establish that relationship is grab the one-to-many key here. And what you want to click first is what the many table are going to be. So there's going to be many posts to one user, right? So we're going to say, click that first, and then that's the anchor there. So it should look like this with the try line here, not at the other end. And the foreign key should be on this table. So we'll call this the user ID. That's the way we've been teaching it here at the dojo. So we'll move this here up now, and so we have two keys. One is the primary key. This is for each post. Each post has an ID. And then the user ID is going to be the name of the user who posted, or the ID of the user that posted. Okay, so that's a one-to-many relationship. So only one user can post at a time. So we'll say that one, there we go, one-to-many. One user to many posts. So we again, grab this here. We click the one that's the many table, and then we click it first, and then click our one table second, and that should establish a one-to-many relationship. Can anyone give me another example of what a one-to-many relationship could be? Any one-to-many relationships, maybe just in real life? Any examples of what one thing to many things in real life?
Sales.
One what?
Sales.
Sales.
Like
All right.
one salesman to many sales. Yeah.
Okay. One salesman to many sales. Anything else? Can can one person have many children? Right? Can a child have many parents? One teacher, many students. Okay, all right. One instructor, one main instructor per class. There we go. Perfect example. One teacher, many students. What's another one? Anything else before we continue? We just want to get a good grasp of one to many before we go to many to many. Right? There's a subtle difference there, but let's think of another one to many relationship.
One
Let's
person, many accounts.
one person can
account.
have many accounts. Sure, I have many different social media accounts. One ant hill, many ants. Johnny, you knocked it out of the park. Okay. One closet, many clothes. Oh, very good. All right. Let's see. Okay, someone else do another good one before we continue, because you guys are on a roll. Last one, someone hit me. One foot to many toes. One closet, many clothes. One album, many songs. All right. We get the picture. One person, many courses. One man, one mission, many relationships. There we go. There's a one to one and one to many. There we go. So now we have a good grasp of a one to many let's get a grasp of many-to-many. We have also many-to-many types of relationship. Now, this one is where the waddies get the waddies get a little muddied. The waters get a little muddied. Okay. So what I mean is that whenever we create a many-to-many relationship, it creates an additional table that holds a foreign key, just as we saw Kyle do. And it was a little bit ahead here. So what I want to do is say I want to say a user a post should be able to be liked, right? Let's say in our social media website we can establish some sort of counting system for likes of posts, right? And one user should be able to like many posts. And one post should be able to be liked by many users, right? So we have that one to or many to many relationship in that instance. And here we can also think of a lot of many to many relationships. And then we start to wonder what's the difference between some of our one-to-ones and many to manys. So let's go through this in the sense where we're talking about likes. Okay, so one user can create many. Oops, I created one by accident. Careful where you click. So when you drag these tables, you don't want to accidentally create a relationship with itself. So I'm going to grab it at the blue title at the very top and make some room for some more tables. I'm going to move this down a little bit. Move. And so I said one user can like many posts, right? So when we say this, we want to grab this tool here where it says, where it looks like it's it's branching out on both ends. That's the many-to-many relationship tool. So you click that and then you click either end. All right. So user to post, and this one here, as soon as you create it, it creates, oh, let's spread this out a little bit so you can see it at a better angle. This one has already been given a title. And so what we want to do is remember what the purpose of this many-to-many relationship is and then rename it. Okay, this is the likes table. This table is created just by virtue of the users and posts both having they have a many-to-many relationship with each other. One post can be liked by many users, and one user can like many posts. And when we create that relationship, it's going to automatically create a table for us there. We have to remember the purpose of that connection that we have between these relationships, and then give it the proper title as you see here, likes. All right. Can there be another many-to-many relationship between users and posts? What do you see common on a social media website that also has many things on what like a post would have? Can a post have many comments? Right? Have you ever seen that on a social media post? Yeah, a post can have many comments by many different users. Right? So that's another one we can establish. We'll say post to users and then create another diagram there. So let's go ahead and, oh, sorry, another table I mean to say. And we'll say this one is the comments table. And so just as an example, right? So we can have many-to-many relationships between two different tables. And these hold these different IDs for the different values. And so you're going to want to go in there and then change that to, well, before we get to that step, let's think, what are some other many-to-many relationships that we can think of? Anyone have any idea of a many-to-many relationship off the top of their head? Just like the real world, Actors to films. There we go. Pizza orders and pizza toppings. Oh, now I'm getting hungry. You know, when I used to I lived in South Korea for a little bit at a time in my life. I was a teacher there. Got a chance to do that. I told my students I played Spider-Man. They believed me. Like, so my relationship to films is 0 to many. I have no parts in any films. In it. All right. Jokes aside, what's another many to many? And then we'll move on. Any other examples? Here we have some. Actors to movies, businesses and cities. There's can be many businesses in different types of cities. And let's say users and interests, right? Hobbies, sports, so on and so forth. Okay, now that we have our diagram, it looks pretty good. It looks clean here, right? I mean, it doesn't look clean, but it looks like it's organized in a sense. Now that we've gotten to this point, we can create our database for this here. And so what we want to do is, if you're on a Mac, you go scroll to the top here and click database. If you're on a PC, well, you still want to go to that very top menu and click database. And you say forward engineer. Okay, when you click forward engineer, you should see this here, this option. You click continue. And then when you get to this page, you click that drop objects before each create object. Click this option here, and it should look like this. You hit continue, and then you type in your password. Mine is root. Okay, and I say okay. And then I click continue again. Then I click continue again. And then I close. And it's done. And so now this is now created as a database in my system somewhere. So in order to find that, I need to go back home here. So I click the home button. And now if I click here, if I click this dolphin with this database thing, and now I click here where it says local instance 3306. I double click it, and now it's going to ask me for my password that I set. I'm going to say root again. Many people, many friends. All right. Okay, so now if I expand my schemas here, these are the different types of databases I have here. And so if I refresh, oh, it's already there. I just missed it. Big old bold letters. All right, social media website database. Here's this database. And if I click that open, I should be able to see my tables. And now here are my tables. All right. So now I can, for example, click this button here. And it will say, as my first query call that you guys have seen, this is asking for information from the database. This is a query. So query means ask or a request, right? So this is our first database query. It's asking to select all. That's what the star means there. All from social media website database dot users. Right? So what's that dot notation mean?
That means that in the entire thing, you're going through the entire database and you're looking up the users.
Yeah.
So
Exactly. Yes. True, but the answer and that is good to know. We're looking at just the users in this sense. We're not looking at anything, every table in the database. We're looking at the users. So that is correct. I do want us to note that. The other thing I want us to note is what Brooke said in the chat, is that this is an object, right? Dot notation means that we're dealing with an object. So that means the whole thing that we have saved here in this whole database is an object as well. So we're grabbing from an object and we're placing it into our object in our server, and then we're serving that information in the object to our front, right? But the way that it's stored in this object, we want to grab that information from this object, put it into the object that we want in our kitchen, right? For the cook, for the server.py, who's going to give it to the front. All right, so let's go ahead and add one entry before we close out. All right, so I'll put an ID of 1. I'll manually enter it in there. I'll say address ID. Oh, sure, we'll just give it an ID of 1 for now. And then first name, we said Tom Bombadil. Said he was 100 years old. 1,000. And he has a long bio. And then if I want to say create this entry, if I say apply, it'll fill in that date time updated at for me. So if I click apply, oh no, it didn't. What did I miss here? Did I need to put in now and now? I hope not.
Hey Josh,
Yes.
where did you get to where you are right now? Really quickly, where you're able to.
Yes. Let me retrace my steps here for us that fell behind. Okay. So once I forward engineered it through that process that I showed, that I had to click forward engineer at the top. So I click home, all right, and then I click to that dolphin there. All right. Once I have that, then I can click local instance 3306. Then well, it's going to ask me to enter my password. I already did that, so it didn't ask me this time. And then it's going to show me a local instance of my current databases. If I already have it open after I created one, all I would have to do is click the refresh to see the one that's most recently created. It's already been created for us, so I don't need to refresh it. And so if I click that caret there to the left of that database symbol, this thing is like a database symbol. It's like a triple cylinder. It's like a can of beans. All right, so we click open this can of beans, and then it says tables. Click open the tables part, and then you go to users. Click open the users. Or you don't have to click open the users. All you have to do now at this point is click this little, I know the symbols are so small, they need to like help us aging people here, but you have to like hover over it in order to see it. So once you're hovering over, I can't even highlight it because if I move my mouse, it's not going to let me highlight it. So here it is. I hover over this users table and these 3 little icons show up. You click the icon to the furthest right here. This one here with the table with the lightning bolt at the very top right. And it takes you here. You know, actually, before I start entering in data and selecting more data, I think here is a good point to leave off on, because if we get to this point, we have successfully gone from creating a schema to a database. Now our database is completely empty. But the point of tomorrow's day is to go enter into our database, right? We're going to do queries. So that's going to be entering in one or many different points of data into our databases. All right. If anyone needs me to go over that step of creating, let's create another ERD here. Let's create another one. We'll call this one ninjas. We'll save the last one we created. Save, and it'll create a model here. I have these saved in a folder called SQL models. And this is in my document. So I like to save my models mostly. And this one is just social media website database. Okay, so oops, excuse me, I clicked a little too fast there. All right. Step 1, you go to home. Then you click the models button. Click it, and then you click the plus sign at the top. Okay, remember this is all recorded in case you get lost. Click the plus sign. Then rename your database. This one I'm going to call ninjas, right? Ninjas. Okay, this is my ninjas database. So I double click here, I enter in, and I click here to this table. I hover over and it says new table. All right, I'm gonna create a table real quick for ninjas. Add in an ID. Okay, auto increment. And let's just give it a simple thing. First name and then a last name. Okay, so our ninja, our whole database for our ninjas is gonna be really simple. Okay, so this is it. That's all we want to be in a database. Just ninjas with first name and last names. Okay, that's all it is. Very simple app. Don't know what the point of it is. I just want to show you guys how to change a schema, an ERD model into like a database. So I hover to the top here. I click database. I say forward engineer. This should take me to this view that I see here. Then I click continue at the bottom right. Then I click drop objects before each create object. All right, make sure that's clicked. Continue. Then enter in my password, root. Okay. Then I click continue. Hit it one more time. And then close it out. Once you see, well, before I close it out, once you see that all these things are checked as you saw here, we are good to go. That means it's been created. It's been created, and we have forward engineer finished successfully. That means our database has been created. So then we close it out, and then I would click this home button. All right, so now I want to exit this area where I'm creating schemas, and I want to go to my actual database. I click the dolphin with the database behind him, and I double click local instance. Then it will tell me to submit my password, but since I'm already logged in, all I would have to do to review all my databases is refresh that there. Now I can see that Ninjas is there and it wasn't before. Okay, when I hit that refresh button, that let me refresh and get a view of all my databases. So now I can hover over the table. Well, I click open the tables. I see here's my Ninja table. And if I want to open him up, there he is. Column ID, first name, last name. And these columns are saved just the way we would see our columns saved in this table from the very beginning, right? So you see here that says there, ID, first name, last name. Here's a column, and then our data is organized into rows. That's the point of today, seeing how a database is organized, how entities relate to one another. Tomorrow, we're going to start pulling and putting information into the database. But for now, we just want to see a big picture of, well, what relationships are between tables and what does that mean as far as how we can access the information through keys called IDs. Now, these are going to come in more to play tomorrow, all the IDs. But we can see here already our first query. It says, select all from ninjas. And because nothing has been created yet, all the values are null, as you can see here. There's no entries. Okay, if you're having trouble reaching this point, then we'll be glad to help you after this recording, after this class. We'll go in depth and troubleshoot as to what we need to get you to this point. But all we need to do is get to this point today. All right. And let's take a look here. What's our end of day assignment? The end of day assignment is to submit an ERD. All right. And so we have here the requirements. We need to have a schema called book schema, and then call a table called users. In our users table, we need to have an ID, name, created at, and updated at. Really simple table, right? And then we also need to create a table called books. Then in the books table, we need to add an ID, title, number of pages, created at, and updated at. Then create a many-to-many relationship between the users and books and rename the joining table to favorites. So that third table that's created, call that one favorites. Instead of users has books. Rename that from users has books to favorites. Then once that's done, change the names to singular pronoun. Make sure that in the foreign key. Oh, something I forgot to mention. But I mentioned when we have foreign keys in general, change it from plural to singular pronoun. So usually it will say users ID, users underscore ID. Change it from users to user ID, and book ID from books ID. Okay. Then once you save it, submit that WMD file. All right. That's what you're submitting here. A MWB file. Excuse me. MWB file. Okay. And that's it. That's your assignment for today. Once you're done with that, read ahead. Okay, read ahead, and we've already done this today, forward engineered it. But what it's gonna let us do is look into the rest of the reading today, which is find out how to select from our table, how to insert into our table. All right, this is create, or how to update, right, or delete. All right, so with that being said, I think we've held you long enough. You guys are good to go. Does anyone have any questions lingering?
How do you create the like export the MWB file?
You want me to do that process again? Sure. Oh, how do I export the NWD file? Okay, let's create one together. Whenever I create a model here, I save it. Right? That last one that I just created, the ninjas one, I'm going to save it as ninjas here. And I have it saved. It's going to ask you where you want to save it and which folder. I have them saved here in a folder I created called MySQL Models. And I save it there. So all I need to do is go to that folder and find that file to submit my assignment. Does that make sense, Nian?
Yes, thank you.
Yeah, so anytime you're working on a model, let's say I'll create a new one here. I'll call this one Pirates, right? So here, Pirates. And this is just going to be a table full of pirates. And it's going to have their ID. It's going to have their name. That's enough. Okay. I will just have to go to File, Save Model As, and it's going to ask me where I want to save it. I'm going to call it Pirates here, and I'll save it to this MySQL Models save. And I just have to pull it from that folder to submit. All right, so how well do we feel about submitting today's assignment? I'm going to poll you guys. How well do we feel about today's assignment and completing it? Submitting a WMD file. WMB. Okay, there should be still somewhat struggle to it. So I think that you guys are getting it. I know it's a lot of information we're throwing at you. I've tried to avoid going over every single definition of what everything means because I get overwhelmed whenever I'm learning something new. And I want to just keep it to a minimal. Now I will probably go back and explain a little bit more about the difference between the dotted lines and the straight lines. And I wanted to answer it today, but since I didn't give a complete answer as much as I wanted to, I will maybe touch up on that in the future. But what I wanted to keep it minimal. Okay, so all we want to do is get to the end of the day assignment books and do tomorrow's reading. And possibly tomorrow's assignment. So let's look at tomorrow's end of day assignment, in case we want to look ahead. So now we're still dealing with tables and we're doing queries. Okay, so tomorrow's all about queries. Getting that information in and out of our table. All right, now everyone, I'll go ahead and end this recording. I'll have all the recordings up within the next 30 minutes. Okay, so I'll go ahead and be working on that now. You guys are free to jump in my room or any of the other instructors or TAs' rooms while I'm doing that. And don't be shy to ask for help. We want you to get through this course with flying stars. Okay, so take advantage of us. And with that being said, you guys have a fantastic rest of your day. Looking forward to Wednesday, week 2, day 3 of Python. So after tomorrow, we only have 1 week until the exam, right? So we want to get mentally prepared, mentally focused, knowing that we still have a lot of learning to do, but that it's coming close. Okay? So, I'll go ahead and stop it now.